3, which is adding potassium to lithium-ion batteries. And this is from an awesome team led by Dr. Lauren Marbella from Columbia University. Her and her team essentially are designing the next generation of lithium-ion batteries. And lithium-ion batteries are in everything we use today, from our phones to our computers to even electric vehicles. And an issue with them right now is that over time, they start to degrade. And what that means is the efficiency is lower, the charge capacity is lower, so your battery won't hold charge as long as you're in your phone, or your car won't be able to drive as far before you have to plug it in. But at the same time, there's also an increasing risk of short-circuiting, fires, and explosions, basically due to the fact that microstructures grow on the electrodes inside the battery.
Okay, so like why, or I guess how are these microstructures formed?
So I like to think of it like this. So when a battery's discharging, it's undergoing a process called stripping, which is basically like you have this perfect rectangle made of a ton of Legos, and stripping is just pulling the outside layer of those Legos off. And that's how charge is transported inside the battery. When you're recharging it, it's undergoing a process called plating, which is like adding those Legos back on right back to where they went before. What happens right now in a lithium-ion battery is essentially during the plating process, it's pretty prone to making mistakes. So you put a Lego in the wrong spot. There's only, it's 2 layers thick of Legos in one spot instead of 1. It's not that bad the first time it happens. But over many cycles of charging and discharging, this tiny little mistake of adding an extra Lego in the wrong spot becomes a huge structure that over time eventually blocks part of the electrode and then can cause short-circuiting and fires and all those bad things like we were talking about before.
Got it. Now, are there like any kind of preventatives being used right now in batteries to make sure that that doesn't happen?
So there's some technology right now that's being used, and they basically add polymers to the electrolyte. And the way I like to think of it is it's like where you start getting that rough surface where you make mistakes with adding the Legos back, they kind of fill it in with putty. So it's preventing more Legos from being used, and what that does is basically it reduces the charge capacity over time. But what it does do is it also prevents, the really catastrophic stuff, the fires, from happening. What's different about this research from Columbia University is they're preventing these mistakes from happening at all in the first place. So you don't need the polymer, which reduces the charge ability of your battery. It kind of attacks both of these criticisms, which are that they're unsafe and they don't last that long. So it makes it last longer and it keeps it safer over time, which I think is really super fascinating.
Wow. Well, shout out to the research team at Columbia. As we move on, especially there's a heightened interest in renewable energy right now. A big problem is where we're going to store it. So lithium-ion batteries have been playing a key role, and making sure that they're safer and more efficient is going to be pivotal to us transitioning from fossil fuels to renewable energy.
I agree, and I'm really excited to see this get integrated into consumer products. So,
Absolutely.
Think about your phone or your computer. Over time, it doesn't lose its ability to hold charge, which would be awesome. For those with a Samsung Note, you also don't have to be worried about being banned from a plane because your phone battery is prone to exploding. For folks with electric vehicles, you don't have to be concerned about your car battery blowing up if you get in a slight crash. And you also don't have to worry about your car losing range over time, which is something that I think is really, really relevant to folks who are interested in buying an EV today, is knowing how the battery is going to perform down the road.